का वो पढ़ना था। Good morning, Tapan sir.
Good morning, ma'am. Yeah, good morning, ma'am. Am I
Good morning.
audible?
So, good morning, dear all participants. I would like to introduce Tapan Jain sir. Dr. Tapan Jain sir is working as head of the department at Department of ETC at IIIT Nagpur. His research areas are machine learning and IoT basically. He is having 17 years of teaching and academic experience. And his today's talk of the topic is based upon foundation of data science and application in various domains. So I welcome you, sir, on behalf of organizing committee and Department of IT SSP CBLI. Welcome to this program sponsored by ICT and IST on the topic data science analytics and visualization tools. Sir, you may start. Thank you, sir, for accepting the invitation.
Thank you, ma'am. Thank you. So,
Yes, sir, audible.
is the screen is visible, ma'am, now?
Yes, sir, you're
Am
audible.
I audible, ma'am?
But your screen is not visible, sir. Yes. Now
And my
screen is
screen is
visible, sir.
now? Okay, okay. The first session of the day, and thank you, Latika ma'am, opportunity to is clear and my screen is visible. So if you have any question, you can put into the chat box or unmute yourself. Online mode, I unable to see the my face and the audience face. So I'll try to deliver in this session about the foundation of data science and its application is various domain. So you feel free interrupt me anytime. So just little bit quickly about my institute. So Triple IT Nagpur basically established in 2016 into Act of Parliament. It's an institute of national importance. Our director is Professor O.G. Kakade from VNIT. Dean is Dr. Ashwin Kothari. And we basically run the three department: basic science and engineering, computer science, and electronics and communication engineering. And we offered BTech and PhD program. Apart from this, we have some certification program. Okay, science foundations. So I'll quickly start with what is the role of the data scientist and where we can play and how to handle the data. So this data science is the amalgamation of the all the hot topics like artificial intelligence, machine learning, blockchain, IoT, big data kind of thing. So here my one screen is shows that the a picture is worth of 1,000 words. So now you can and the photographs or the status photo. So we have the huge volume of the image data, and each of the image consists of thousand of words. So now you can imagine the volume of the data with respect to image only. We have talked about only one dimension. If we consider the image part, we have the huge data. Similarly, now you can involve this second slide, this word. Now this word in last 1 year, we have the lot of data related to the COVID-19 or Corona or coronavirus messages related to the COVID-19. The status of your city, what is the current status of your hospital and medical facility. Many of the person floating the message how to cure and how to stay safe. So a lot of data volume is related to only this one single word. So how do we taken care of these so much of data? So here the data scientists play a very crucial role. So I'll tell you the what is the data scientist and where you can lies in the this particular model, and how to take the things award and become a data scientist. So we'll talk about these things in our later slides. Okay. So basically this is the basic figure of the data scientist, and this is the data science in the center, the computer science or IT background. So here IT background, not related to you are very comfortable in any of the language, but if you have some Excel sheet, right, and if you have some and you have some mathematical background. For example, you give the marks of your class, what is the maximum number of in the class, minimum number of the class, how do we assign the grading kind of thing. So these come lies into the maths and statistics part. And when we combine computer expertise with maths and statistics, it become a machine learning. Okay. And then probably if you work on the some industry, or let's say for teaching, so your job is basically a domain knowledge. So for example, you are a electronics and communication engineering, and your favorite subject is analog and digital field. So knowledge of your particular field or domain, when we interact with the domain knowledge with the computer science or IT peripheral, which is the form of software development. And when you have the knowledge of your domain and you have the idea about the maths and statistics that combine the traditional research. So now you have machine learning, you have knowledge of the software development, you have the traditional research knowledge, and it is formed the data science. So so for example, I'll show you what is the importance of this
Sir,
particular
sorry to interrupt you. Tapan
field.
sir.
So suppose here I'll
Sir, your
type
voice is breaking actually in between.
yes, ma'am. Yes,
Sir,
madam.
sir, your voice is breaking in between.
Okay. So can I rejoin, or so can I rejoin, madam, or what should I do? I can once again I can try to rejoin it.
Now, ma'am, it's clear. Am I audible, ma'am?
Sir, now it's clear, sir.
Thank you. Thank you. I'll, and I'll go into Google and I download the rupees rate is somewhere around 74 rupees something, right? So when we have some data here, and I have downloaded these last 1 year data, right? So if we want to calculate on this case,
Sir, you're not audible, Tapan sir. Yes, sir, now you're audible.
yeah, okay, sorry. So website, there the lot of data is available in the excelrates.com. So this is the data. So you can easy to free access the last 20 years the currency data. So I downloaded the last 1 year data time span of my dollar to rupees conversions, and when I go to the Excel and just download my I don't know what happened in this data. So when I download this data, so the conversion is there. We want to calculate the average value of the last month data. So I don't know what happened. It's okay. Sorry. and I just quickly calculate the maximum value. So we'll observe that now you have one IT skill. Now you have one IT skill, that is the Excel. And you have some mathematical and statistics knowledge, because you have calculated the maximum value, minimum value, average value. Yes. And also you have some, the domain knowledge of this particular field, because when you apply any you have the target or some outcome of your algorithm. So my outcome is my domain knowledge state that ki on 30th November, on 30th November 2020, maybe the dollar pricing maybe somewhere around 75 rupees, somewhere around 75 rupees. That means my dollar value going up. So this is what, this is your domain knowledge. So I have one IT knowledge, I have one IT knowledge, I have the mathematical knowledge, I have the domain knowledge. So when you combine these three knowledge, these three domains, rather say that, so you become a data scientist. So mathematic and statistical knowledge, you become only a machine learning expert, not the data science experts. So keep in mind, whenever you work on the data science part, you should know all three things. IT skills, IT skills maybe you can work on the Python, R programming, Excel or Java, whatever. Okay. And mathematical and statistics is essential. Why it is essential? because because that knowledge is not change, that domain is not change. You should know the mathematical and statistical part of it. IT skill you may change as per your convenience. You can do it. Or nowadays the lot of repository is available. You can download the program, put it your database link, calculate the result. That is what you want to apply. How to observe your data? Is your data is very useful or not? So for these things, you know the mathematical and statistical part and the domain knowledge part. So I'm sure in the later slide, in the later sessions, you also discuss about the data pre-processing. So these three things is, whenever we work on the foundation of data science, these three domains you should know. Okay. So now I'm moving to the next my slide. So this is the typically,
Sir, sorry, sir. Hello. Hello.
yes,
Sir, I want to
yes,
know about the domain knowledge again, sir. Domain, what is the domain
yeah.
knowledge,
Am
sir?
I audible,
Please
sir?
explain. Yes, sir, you are audible, sir. Sir, I want to know what is the domain knowledge, sir?
Okay, okay, fine. Right. I'll explain. Good question asked by the sir. So, sir, here I'll take the one example. I take the data, last 1 year, starting from yesterday to last 1 year data of the 24th November till 2019. Right. So your data is available on a lot of sites. So I downloaded and simply apply something. But can you tell me why this fluctuation come into the picture? Means here, if you observe the data closely, observe the data from 9th and 10th November. Yeah, look at this here. The entire data in my October is 73 rupees. And if you look look the data from the somewhere around June is the 75 or 76 rupees. So my data domain knowledge is state that if you are expert or if you are a very good broker, or you are dealing with the corporate client in US or Europe, so the weightage of the dollar. For example, I am the teacher, and I am not interested to work in the US and Europe, so I don't bother about the transition of the conversion of the dollar to rupees or rupees to dollar. So here the domain knowledge or domain expert play important role, whether the US election is happen, or maybe the India election is happen, where acquire some big company in US. So like that, most many factors depend upon this convergence. So that convergence, the people who are the expert in this field, they can predict easily whether my dollar rate is domain knowledge. For example, if you are the civil engineer, so the better idea about the component, when make construct any building or any project. So that is the domain knowledge. So that is the raw materials, and I'll say you just consider the civil engineer are the expert who have the things better rather than the unexperienced or inexperienced person. So here the domain knowledge is essential, or you can say required. I'll tell you in the brief about in my slide also why it is important. So just complete this slide, and then I does the answer of your question is clear, I suppose. So this is the data cycle. As I told you, the data is coming from the different sensor measurement, IoT devices, text messages, images, audio video files, or industrial IoT material which has to be synthesized and extract the informations. So we have the big data warehouse, and we have the huge voluminous data. And then my job is, suppose I am working on the finance domain, so I need the finances related data. So I request for the not the entire data. So my job is, suppose I am belongs to the finance company, so I request for the
Tapan sir, you're not audible, I think.
Sir, you're not audible,
Once
sir.
again, I remove headphone. Now I am audible. Just a moment.
I think there is some network issue. your end. Yes, sir. Now you are audible.
Am I audible? No? Mute. So I don't know what happened. Okay. Let's once again, I'll try. I'll explain the slide. So this is the role of upper curve blocks is the role of the data scientist. So the certain what is my customer liabilities, what they have the number of credit cards, what is the outstanding loan amount, what is the amount in your saving accounts, and what is your different products related to the finance, number of FD, RD, and so I request for my data engineers to provide the certain data of my customers, maybe in the state of Maharashtra. So I request for the data engineers, so they fetch the data from the data warehouse, because data warehouse is the very voluminous of data. So it is not possible to apply any mechanism of entire data warehouse. So I can request especially my data engineers to provide these kind of data. On the request of the data by the analyst, data warehouse engineer extract these kind of tables or columns and provide the data preparations. So data preparation may be arrange your different type of data in the certain format, maybe Excel format, maybe a CSV format, or maybe a database. Once you have the related data, you apply the data cleaning mechanism. As I told you that if any of the row or columns is empty, we can simply remove that particular row because they will give you the wrong interpretation or wrong predictions or wrong results. So we delete that data for data cleaning. Or also sometimes we have the outlier, so we delete that data and prepare the data and send it to the data analyst part. Data analyst part is not the very big role, as I see that, because its role is only the visualizations. Only the visualizations. There is no prediction, no machine learning is involved as a role of data analytics. So just just he will, because this data is very huge, very voluminous. For example, if I stored the last 1 year data, so I required 300 and somewhere around 70 lines for last 1 year data for one particular column. So suppose you have 10-20 features and you have thousands of records. So it is not possible to look at each and every data rows. So we'll just do the visualizations either in the pie chart or the bar chart or some other tools, how to visualize the data in one page. So the data analysis job is to entire data to summarize in the beautiful figures, so we can extract the information in one go. Now, when we talk about the predictions, so whether this customer is useful or potential customer for the finance domain, so we do the modeling. What do you mean by modeling? We apply some sophisticated algorithms of artificial intelligence and machine learning, evaluate some certain parameters. Once you apply a particular algorithm and it is fit for my particular data, I deploy it into the real-time applications, or suppose I deploy for the Maharashtra customer, then I can deploy for the pan-India program to entire nation or entire state. We can deploy this particular algorithm. Then the role of the domain expert is come into the picture, or the business understanding, whether this data is useful or it is not in use in our future requirement. So now here the domain expert or the banking expert decide whether this data, predicted data, may be useful or not. If it is useful, it is sent to the data warehouse so that the volume of data warehouse now increase. If it is not useful, they simply discard the data. There is no use of data for the future transaction. So this is the complete role how the data warehouse is evolved. So finally the domain expert will decide whether we want to add this data into the warehouse or not, right? So sir, this is the domain expert knowledge is required. So here the big bankers will decide these kind of algorithms or deployment is useful for certain applications or not. If it is useful, the volume of data warehouses increases. If it is not useful, we simply discard this data. So this is the complete life cycle of the data science. So after the data analysis, the machine learning or artificial intelligence come into the picture. These 4 purple lines block is very, very useful for the data sciences. And the data valuation and data is come into the picture where we can apply the algorithms, right? So I hope, sir, that answer is clear for the domain expert, maybe. The next important point is the what is my data types. Is my voice is clear now?
Yes, sir, it's clear. In between, it is breaking somewhere.
Oh my God. Okay, I'll check because here the connectivity is fine and I don't have use any kind of mic and nothing. Okay, let's see. So now come into the data types. So here the data type is not exactly which I'm using in the my C or C++ programming, like integer, float, character. Not here. The data type is when we do the data processing or data cleaning or preparation of the data, we just understand what type of data is this in particular file. What type of data is this? Why? Because to apply certain algorithms or the execution of the query or query optimization, we actually time interval. Certain time interval, or you can say that the float will take out. Part discrete means one example. Suppose one telecaller receive calls per day. So number of calls received per day, you can say it is a discrete in number. But at what exactly the time and the duration of the call that then decide into the continuous part. Why? Because this fraction values come into the picture, not the integer count. So here we can divide my data into 2 parts, continuous as well as the discrete. Now the second data type is the categorical data type. It is a very interesting data type. It is the 3 basically in the nature. Nominal, I can take the example. Suppose we all have these smartphones. So now I can divide my smartphone based on my operating systems. So suppose the 50% person having the Android OS, 35% having the Apple OS, 7% having the BlackBerry OS, 4% having the Windows OS, and remaining the rest of the 4% is the some other. So I divided into the five category. So Android, Apple, BlackBerry, Windows, and others. So any of the smartphone falls into one of the category. Similarly, I'll take the example of the TV screen. So maybe your TV screen may be the plasma, or maybe LCD, LED, or OLED, or 4K, whatever. So if you the number of the category when you fix, so that fall into the nominal category. But if you have only the two category, the spatial type is only two category, that means it is the binary category. Maybe the binary category may be yes or no, true or false, right? Whether it is a LED TV or not, like that. And then the spatial type of this categorical is the ordinal means. Ordinal means when we perform some kind of feedback of my students, when we take the class, I'll take the feedback. So not normally we have to use one kind of order. So rate the teaching in the out of 1 to 5. So 1, 2, 3, 4, 5, where 1 is the excellent, 2 is very good, 3 is good, 4th is average, 5th is poor, or vice versa. So if you have the ordered category, right, that fall into the ordinal ones. So whenever we prepare our data, whenever we apply something, algorithms or visualizations, first we need to divide my data into the data types, whether it is a numerical data or whether it is a categorical data. If it is the numerical, then again divide into two parts like that. So this is the data types when we do the analysis or the data scientist job. So first thing, you have to divide your data into the important data types. Now we talk about something about the data types. Now come into so whenever we work on the visualization part, so basically we have the some data into the rectangular format, some data into the, you can say, my data is in the rectangular format. So here I'll tell you, this is my F1, this is my F2, this is my F3, this is my F4, and this is, you can say, my output, and this is my R1, R2, R3, R4, R10, and so on. So whenever we talk about the data, always the data available into the rectangular format. This rectangular format is also known as data frame. This is known as the what? Data frame. And the column, basically a column is nothing but your features. Column is nothing but your features. So column is nothing but your features. And rows means your record. Rows means your record. Rows means your record, or you can say my input. And in the last column, some of the data is the output is available. Some of the data is output is available. Maybe in the categorical format or binary format or anything else. So some of the data is, you can say, my data is labeled. The output is present. So suppose here the output look like this. So this is nothing but this is your outcome. This is nothing but your target, or you can say outcome, or you can say my output, like that. So Number one important point is whenever you have the data, number one, it is always in the rectangular frame that is known as the data frame. Your column is nothing but your number of features. Your rows is nothing but your number of records. You can say the input values. Sometimes this output column is present or sometime it is not present. So if it is present, that means my data is labeled. If it is present, that means my data is labeled. Otherwise, it's not labeled. So basis on this labeled and not labeled, in later sessions, you will, decide whether which type of algorithm can use. If my data is labeled, then we'll go for supervised learning. If data is not labeled, we'll go for supervised learning, right? So important point is you just keep in mind what are the columns, what are the rows, what are the targets, what is data frame, like that. Okay. So I hope this point is clear in terms of the data, right? And then suppose some features is available. Some features, let's say this feature is nothing but the age. Age is there. So maybe the age is 40 or 41 or let's say 46 or maybe 35 or maybe 30. Or suppose this is the age of our employee, and employee, age is ranging from, let's say, for example, in our company is 21 to, let's say, 60, right? Sometime by mistake, when we, do the data entry and when we fetch the data, by mistake, suppose the data is, let's say, instead of 31, if I type the 30, this is the wrong data interpretations. So when these type of record, when we find in the particular feature of F2, we simply, delete this data. Or maybe the data, maybe instead of 13, 3, will type, suppose the value is, let's say, for example, 83. So sometimes this value is not appropriate. These values are known as the outlier, right? So we can do the thing in the process of data cleaning. We simply remove this data. We simply remove this data. That is known as the data cleaning. So what? My age ranges belongs to 21 to 60, but somehow when we enter the data or when we collect the data, this value is not fall into this particular range. So we simply discard this data for data cleaning. Otherwise, it will give you the wrong prediction or wrong visualization, wrong results, right? So this is the one type of data cleaning. Simply observe your data values and then you can predict. Okay. So basis on this, we will decide whether, basis on this, we have some estimation parameters. Now here we'll talk about something which is very essential as a data scientist for foundation. As I told you, IT skill is not necessary to require, but the skill of mathematics and statistics is very essential. So here we all know what do you mean by the mean. So average, simple, the sum of all the values and divided the number of values is already calculated when we convert the dollar to rupee conversion, and 1 year average value we had already calculated. So this is the mean. But what happened when we work on the real life applications? So we collect the data from different sensors. So some of the data will give you the accurate value, and some of the sensors will give you some deviated values. So to fix this value, we have to adjust or we have to give some weightage for particular sensor reading. So in real-time applications, basically we use the weighted mean. What do you mean by weighted mean? In every census, we multiply some weight, add up all these weights, some product of weight into the reading, and divided by the number of weights. That is known as the weighted means. So most of the application will, because nowadays the data is coming from different sources. So basically the environment, when we come the data from different sources, this environment is known as the heterogeneous environment. So when we apply the estimation of the average value, we prefer the weighted mean. Why? Because data is coming from different sources. They have the different values. To set the values, we'll use the weighted mean concept. Number third one is, you all know the median. Median is simply arranging all the data, and the centermost data is, or you can call as the 50 percentile of data is your median. Similarly, when we arrange the data, some of the sources having very small value, not amplified one, some of having the very high exposure values. So calculate this median is very difficult. So we can calculate the weighted mean. So whatever the small values first we amplify, then arranging into the ascending order and calculated the weighted mean, right? So this is a very important concept of weighted mean and median in your estimation, or you can say rather than the location-based estimations. Then the important point is the trimmed mean. So basically trimmed mean is used when the data is very huge, very voluminous. All right, so for example, I have the 60 students in my class, and I'll calculate the average. And when I enter the number in the Excel sheet, instead of 40, I enter 400. Instead of 40, I enter the 400. So when we arrange this data into the ascending order, so one of the data is very far from the existing entry. One of the data is very far from the existing entry. So we do one thing, when you have the huge data and you don't know the range of that particular data. So we'll collect the data, arrange into the ascending order, and trimmed from the initial part and the final part. We trim the initial part and the final part, and will capture the sum of the center data and calculate the mean. So this is known as the truncated mean, or you can call as the trimmed mean. Clear? So you have voluminous of data. When you arrange that, so for example, your marks is ranging from, the passing marks is ranging from 40 to 100, but the sum of having the by mistake a negative number or less than 40, and some of the candidate number having more than 100. So that will give you the wrong results. So we can discard these entries from initial part as well as the final part and calculate the mean. So that is known as the trimmed mean. Then the robustness. So robustness means the not sensitive to extreme values. Now here the very big difference between the robustness and the outlier. So suppose my data in my class of 60 students, the marks of one of the student is 400. That is the entire difference of my all remaining 59 students. So that is known as the outlier. We simply discard that particular data. We simply discard that particular data, and I'll tell you this is the outlier, right? Or we can calculate the trimmed mean in this case. But the robustness is what? Suppose you are entering the customer wise their account status, or what is the the current position of their saving accounts. So suppose you can enter the value like, let's say 1 lakh, 1 lakh, 1 lakh, 1 lakh, and all of a sudden then the one of the customer having the 1 crore rupees in the account, and then again the 2 lakhs, 3 lakhs, 4 lakhs, 1 lakh, 50,000 like that, and then the one of the entries come into the 2.5 crores. So these are not the outlier. how your system is capable to sense and adapt that extreme values, that is known as the robustness. That is known as the resistance, right? So here it is not the marks. Here the what is the your amount in your saving account. So how robust is this? So some accounts having the zero balance as well. Some account having the balance is 1 lakh rupees, and very few accounts in the bank having the the balance is crore of rupees. So that is nothing but, it is not the outlier, it is the robustness, how the system is adopt these much of values. So number one is, whenever you start the data, first you divide your data into the data types, and then this is one of the estimation, that is the location based estimation. This is very easy but very powerful to prepare your data and give the results. So for example, in this case, you can simply say that in last 1 year, my average dollar cost is 74 rupees. My minimum value is 70 rupees. My maximum value is 78 rupees. The standard deviation is 2 point something rupees. And like that, or you can tell the median value is somewhere around 73 rupees. Like that, you can, predict or not predict, you can calculate the values. And basis on this, based on the domain expert, on that particular data, they can predict the on 30th of November, the estimated value of my $1 is equivalent to 76 rupees. Like that, they can predict. Right. So I hope the 7 point is clear. It is a very basic point related to the estimation. Okay. So if you have any question, look into the chat box and. Okay, so no more questions, so we'll continue our slide. Okay, so this is the second dimension of the estimation, is the variability base, right? So when we do the estimations, we have to, observe the values very precisely in the sense, what is your estimated value and what is your observed value. If you take the difference, sometime it is known as the deviation, sometime it is known as the error. So basically in the neural network part, we we have these some estimated values and observed value, and we just calculate the error. So sometime the error is in the positive and sometime error is in the negative directions. So our aim is to minimize the square of the error. Our aim is to minimize the square of the error. So ultimately, how to calculate the square? It is a deviation square. So this is the very important parameter when we talk about the neural network. So the difference between observed value and estimated value, that is the error, and you square up this error and plot based on the recurrent observations, so that error is to be minimized. Your aim is, your objective function is, you have to minimize this particular error. So this is the deviation. And when you square this deviation, as I told you, because sometimes this is error in the negative and sometimes it is positive. So if you add these deviations, so maybe that will give you the wrong results. Suppose one time I observe the error is +2, and second time I observe the error is -2. When you add these two transactions, so your deviation or error is equals to 0. So, but there is a lot of variations in my result, then to my error is 0. So to avoid this confusion, we always take the square of the deviation. So square of the deviation and divide the number of observation is known as your variance, or you can call as the mean square error. And when you sum up all these variances and take out the square root, that is known as the standard deviations. And it is also known as the L2 norms or Euclidean norms. So for example, when when we calculate the actual distance in the coordinate system, x1 minus x2 square plus y1 minus y2 square whole under root. So square and under root. So whenever we talk about the square and under root, that is the Euclidean norms or L2 norms, because we first use square and then square, right? And similarly, if you take the modulus value of this error, okay, is observed minus estimated, and take the mod value, that is known as the absolute deviation. Or because there is no squaring, only the power is 1, so this is known as L1 norms and also known as the Manhattan norms. So what is Manhattan distance? X1 minus x2 mod plus y1 minus y2. That is the Manhattan norms or Manhattan distance. So estimation variability is basically based on the deviation. Similarly, when you arrange these deviations into the ascending orders, absolute deviation, and find out the median of that particular deviation. So that is known as the absolute deviation. Then in my example, if I observe the maximum value of dollar conversion, let's say 76 rupees, and minimum value is, let's say in last 1 year is 70 rupees. So I can easily find out the range, that is largest 76 minus the smallest, that is 70 in my data set. So range is what? 6. So range is also useful to avoid the wrong values.
Sir, sorry for
So range is
interrupting
very
you.
crucial role.
Yes, sir,
Yes,
sorry for
please.
interrupting you. Sir, if just please you correct me if I'm wrong. Here it's written variance, the sum of squared deviations from the mean divided by n minus 1. So,
Okay.
in case of standard error, it will be n minus 1, I think. In case of variance, it will be 1 n only, if I'm not mistaken.
Okay. Absolutely correct, sir. Absolutely correct. But the problem is, I'll tell you why I'll take the n minus 1, because there is no difference if you take n minus 1 or n, because here we will talk about the data sciences and very huge data. So suppose you have the lakhs of data, right? So if you substitute the n or n minus 1, they won't give you the wrong error, because in this time we have to, out of n dimensional data, we have to take the n minus 1 values and predict the nth one. That's why I'll write n minus 1. Absolutely correct. You are right, sir. Are you taking either n minus 1 or n? Both are the same in nature, because the volume of the data, number of records is very large, sir. Here I'm not talking about the 10 or 20 records. Here I'm talking about the thousands of records. That's why. So you're absolutely right, sir. Either you can take n minus 1 or n. Okay. Okay, sir.
Thank you, sir. Thank you, sir. It's okay.
Okay. So here, basically, we observe that data in the variability, the range and deviation, the number 1 and 6 play the very important role, because once you know the data set range, then you can easily, observe the outlier. Or if the range is very large, that means your system is very robust. Your resistance power of the system is very high, but it will give you the complex calculations in this case. Then the order statistics. Order statistics, so basically, because it is not I am talking about the one features, I am talking about the n number of features. So n number of features, when we arrange into the, again, ascending order format, so typically the statistics is very large. So to convert this, we have to calculate the ranks. So that means the how many features are give you the precisely results. So this is also a very important context. So suppose you have 10 features in your problem. So all the 10 features is play the equal role, or one of the feature is very important, or one of the features is no role. So how do we decide? This decide with the order statistics. Okay. So it is not necessary that you will take the, all the features in your problem statement. Then the percentile, we already talk about the percentile, like median, that is the 50 percentile. So sometimes we have, divided my entire data into different portions. So for example, I'll tell you, we want to calculate the histogram of an image. So when we calculate the histogram of the image size, suppose is very large, 1024 by 1024. And we have to calculate the histogram equalization of an image. But it is very large. So we'll, instead of do the global equalization, we divided my image into the 4 parts. So 512 by 512, or divided by the 16 parts, 256 by 256. So take out the 256 by 266, right? Calculate the histogram equalizations. So I can, divide my image into the 16 part, or the sub part, or sub module, and calculate the all the estimated parameters of that. So this is the instead of global, you do the local processing, or sometimes it is very useful to perform a parallel processing. So percentile means if you take out the some p values and 100 minus p values and do the your statistics, or do your estimations. Similarly, if you talk the top 25 and the final 25, or the results, if you talk about, that is known as the interquartile range. That means a 75 percentile and the 25 percentile. So this is just talk about the, briefly talk about the our estimations or variability part. So the one dimension is location, another dimension is the variability. Now, the next point is, I hope this part is clear, is related to the foundation part. Now I just go to the analysis part, or exploring the distribution of the data. Now, number one, we have already studied the estimation in location based. Estimation is variability based. So here is no picture is come into the, only the values is come. Only the values, output values is come. No visualization in this part. But when we talk about the exploring the distribution part, how data is showing into the one figure, because it is not possible to look the entire data context, because it consists of legs of rows. So data can be distributed through the plot or chart. So one of the distribution is maybe in the hands-on session, or the next sessions, or you can just explore. I'll share my slide. You can explore directly onto the Python. There's a 1 or 2 line code, so you can plot immediately. So the box plot is there. It is the fast visualizations, just X and Y plot, and then the put it into the box format, or you can say that the convert the entire data space into the local part or box. So you can just analyze which box is very important in my case. Frequency table. So as I give you the example of the histogram. So histogram is what? Or what do you mean by the histogram of an image? So basically, images consist of the different grayscale label. Maybe if it is 8-bit image, it ranging from 0 to 256. And suppose I have the image of 256 by 256. So I have 256 by 256 pixels. So the plot between the frequency table means you just set the interval, let's say 0 to 50, 50 to 100, 100 to 150, 150 to 200, and 200 to 255. So you divided my values in 5 bins and put it to the number of pixels, that is the frequency table. And in each particular count, if represent, for example, 0 intensity, I have 20 pixel. 1 intensity, I have 30 pixel. 254 intensity, I have 100 pixel. 255, I have 90 pixel. So when every intensity, if you plot the values or frequency of occurrence, that is known as the histogram plot. Then the smooth version of the histogram, it is known as the density. Density means a point. Density means a point which is created. So you can clearly observe that this particular is highly dense area. That means the pixel belongs to this particular bin is very high. It's somewhat, related to the refined form of the frequency table. That is the density form. Then the here the distribution of the data through plot and chart, and now the categorical data. So when we talk about the categorical data, so the mode is the important component. We had not discussed so far the mode. Mode is just nothing but if you observe your data, so the most occurrence data. So for example, you have 10 samples and the ranging from 1 to 10, and suppose the 7 is come into thrice, the maximum time. The mode of this data sample is 7. So when you plot the histogram and the maximum value appear, maximum frequency occurrence is your mode of data. So when we talk about the mode, and so basically we prefer the two category of chart. One is the bar chart and one is the pie chart. So pie chart is basically the circular chart with divided into the percentage, and bar chart is basically the if you part in between the XY format and the frequency proportion. Like so, this is also the useful context to visualization of the data. Similarly, when we go for the data and when we comparison come into the picture, right? So we have the how much data is correlated to my another data set. So that time we are using the correlation coefficients, right? And also we can find out the correlation matrix, right? So basically correlation matrix is the number of variables if you plot in the more than one variables, right? More than one features, and you have to plot. So suppose the data set 1, you have the, like suppose you have F1 features, F2 features, F3 features of data set 1. And similarly, the F1 features, F2 features, or F3 features of data set 2. And when you construct this, relation between the correlation between the F1 to F1, F1 to F2, F1 to F3, and when you construct a matrix with the help of the correlation coefficient, this is known as the your correlation matrix. And then the next is the scatter plot. Now these values when come into the for one particular variable of correlation is plot into the XY axis, that will give you the scattered value results. So these are the some observations of my presentation, right? And if you have any question, you can ask now. Otherwise, we'll take up one or two applications or one or two algorithms. Any questions so far?
Hello.
Hello, yes.
Yeah, good afternoon, sir. Sir, I am Akshay
Badai.
from RGPB Bhopal, and I want to ask one
Okay.
question: is that your data applications are very much authentic for each and every kind of data in every circumstances?
Your question is your data?
Applications will be authentic for each and every kind of data.
Okay, so
Sir,
yes, definitely when we construct any application or when we design any kind of product, our aim is to 100% accuracy. Although it is
yes,
not possible when we talk about the data science, because the data is very voluminous, very huge. So that's why when we talk about the data science, we'll basically do the soft computing.
okay, sir.
So basically, we get into the soft computing. So the soft computing means, I'll give you one example. For example, you want to calculate the value of sine 90 degree or sine pi by 2. For
Okay,
hard computing, the value is 1, but in soft computing, maybe the value is 0.99999. So that much of the changes is always into the picture, right? So yes, definitely, because our aim is to design the authentic applications. And if your question is also correlated with the security point of view of my data, so I'm not the right person to give this answer. So yes, authenticity based is on the security, also the important aspects of this voluminous data. Okay, so does
okay.
the
Thank
answer,
you, sir.
Akshay?
Okay, thank you, sir.
Okay.
Sir, I have
Yeah,
a
in the
question. Hello, sir. Can you hear me?
yes, please go ahead.
So while talking on correlation coefficient, are you
Yes.
referring on Pearson correlation coefficient or Spearman correlation coefficient?
No, yes, this is a good question, sir. I'm not going into the depth, but the problem is it number one, as I told you, when you start any process, so first you have to observe the what type of data type. Then only we are able to predict the something. So for example, the same thing we have to perform in the our image also. So images correlation is basically not exactly the correlation coefficient, but we are using the similarity structure matrix, right? So yes, it definitely, sir, it depends upon the data type. Not exactly you can start with the I am applying the method one for my data. It is not necessary. It is definitely correlated with your data. Okay, sir. The
Thank you, sir.
question, yeah, thank you. The question asked in the chat box by Pradeep sir, how can we distinguish between the truncated mean and outlier? So, sir, I'll tell you the truncated mean is entirely different from the outlier. Okay, so because when you observe your entire data set, first you define somewhere the range, right? So, just say I'll take the example of the answer or marks of my students. So obviously it is ranging from 0 to 100, right? So if you know the range, then only you can calculate the mean and you can observe the outlier. But the second example, I'll tell you the amount in my saving account. So somebody having the zero, somebody having the thousand, and somebody having the crores of rupees. So that is the resistance power. That is not the outlier. So if you have the range and the volume is very high, you can apply the truncated mean. But if you talk about the resistance power or robustness of the system, you cannot apply the truncated mean part. Any more question? Okay, so I'll simply take one applications and Okay. So I'll tell you, yeah, here one application currently I'm working on that application. So in Maharashtra, you know the number of substations, and so we'll take the roughly figure somewhere around, let's say, 3,000 substations. So my aim is to, basis on my machine learning or the visualizations, I have to incorporate that the, I have to predict the health of the transformer. Right. So suppose I have 3,000 substations and each comprises on, let's say, a transformer. I'm not talking about the local. I'll just talk about the transformer in the substation. So we have somewhere around 30,000, suppose, transformer, big transformer. But if we talk about the health of the transformer, we have the requirement of certain data on why we required this kind of health prediction, because once the one of the transformer is not working, it is take lots of time to change that transformer, because it is very huge in size, and the installation of that transformer take a lot of time. And once it is take a lot of time, the you have to interrupt your power supply of that particular area for a longer time. So one of the application is, let's say, the prediction or health prediction of the transformer. So roughly around the 30,000 transformer, and each having the lot of tests, because I am not the electrical engineer, so I'm not aware at that time how many different tests of the transformer, but maybe there are hundred of types of tests for the transformer, and there the frequency is different, right? So I have just studied the two or three, the open circuit test or no load test or short circuit test, like this. But there are the 100 tests, and their frequency is also different, right? 100 tests, and the, let's say, frequency, some of the have the continuous response, some of test in the hourly basis, some of test is daily basis, weekly, like that. So if I take the 100 tests and their frequency of day maybe 100, so the total observation, if we calculate for 3,000 substation, as and each consists of 10 transformer, and having the 100 kind of test, and this frequency, maybe I'll take the 100. So now you can imagine what is the size. So that the test volume is somewhere around 3 into 10 raised to power 9. 3 into 10 raised to power 9. So my point is that for one day in Maharashtra state only, they have the around 3 into 10 raised to power 9 test data of the different transformers. So how do we analyze? So we can analyze with the different parameters, and we can also easily predict the health of the transformer. So for that particular location, suppose you conducted 100 tests on 100 times for one day. Similarly, these are the 3,000 locations. So they involve a lot of sensors data. Once you have the census data in one particular location, you have to upload it onto the center location. Let's say Maharashtra, you have to upload it into the Pune. So this volume is very high. So you have to upload the data, you have to use the cloud computing, number two. Now, this data is easily, tempered. So for that, you have to provide the security of the data. Once you all the data onto the cloud server, then you have to apply the machine learning algorithms, visualization algorithms, or mapping algorithms. You can predict, for example, the Aurangabad transformer substation maybe work another 15 days, or Nagpur sub transformer may be working on another 15 days. So you can predict the you require the cloud computing knowledge, you require the security knowledge, you require the machine learning AI knowledge, you require the visualization knowledge, you require the hardcore programming to visualization these units of knowledge. And then basis on these data, you have to share with the respective department to change that particular transformer, like that. So one applications, very small application of predict the health of the transformer will give you the 3 into 10 to the power 9 data sets values, 9 samples in one day. So now you can imagine the volume of that particular data. So there are a lot of scope in this. You just find out the applications. There are a lot of scope. Financial transactions, you can predict whether this particular customer is defaulter or not, based on the different parameters like number of credit card, number of outstanding loan amount, number of amount in your saving or current accounts, or other assets, liability. Based on you can predict the customer behavior. That is also one of the applications. You can also apply these applications in image processing tool as well, health predictions. So there are n number of applications, but due to the constraint of the time constraint, I am unable to explain the lot of applications. But in my slide, I can share you. So these basic foundation knowledge, you can work on the application, different domain of applications. So is there any more question from your side, or madam, should I stop here?
Audience, participants, you may type the questions in the chat box if you are having, or you may unmute yourself. I think no questions there.
Okay. So thank you, Latika madam, to give this opportunity to interact with
Thank you, sir. Thank you very much for your time and for such a wonderful session. Thank you for accepting my invitation. Sir, can you hear me? Okay. Okay. Thank you, sir. Thank you very much. Thank you for accepting the invitation. And thank you for
yes, ma'am. You're audible.
Okay.
Thank you, ma'am.